Algebras. Welcome to your Chapter 6, Lesson 5 notes. We are going to talk about multiplying special binomials momentarily. But before we do, let's review all of the work we've done so far in Chapter 6 with polynomials and kind of take a peek at some of these different scenarios and situations to make sure we're comfortable. And then we'll look at some special cases. Okay? So let's start with number 1. And we see a plus sign between these two separate polynomials. So that means we need to look for like terms and combine them. So let's see, we've got, right here. Oh, hey, those are opposites of each other. So those are actually going to cancel out when they combine. And then here we've got a 4 and a 5 as constants and just an x squared. So these end up canceling out. X squared is my first term. And 4 plus 5 is plus 9. There's my final answer. Now, in this one, it's a minus in front of the set of parentheses. So we distribute and we change all these signs first, and then we combine like terms. So this time, the 3x and the 3x add up to 6x. We, of course, put the negative x squared first, then the plus 6x, and now it's going to be 4 minus 5 is negative 1 at the end. So that makes a big difference if you've got that minus sign in front of the set of parentheses. Distribute that minus first, then combine your like terms. All right, 3 squared, 3 times 3 is 9. 7 times 7 is 49. Negative 2 times negative 2 is positive 4. And negative 5 times negative 5 is positive 25. So just a quick review of squaring things. Notice that when you square a positive number, you get a positive answer. And when you square a negative number, you get a positive answer. So notice that. Okay, now we'll do a quick review of exponents rules first, and then I'll simplify my answer. Okay, so 2 cubed times 4 cubed. Well, we've got the same base. So add the exponents. So you get 2 to the 7th power. And right here in my graphing calculator, I'm just going to do 2 caret and the 7. So I'm going 2 to the 7th power to get 128 as my final answer. Okay. And that I could do because I had a base that was an actual constant, not a variable base. So that's the reason I was able to do that there. Versus here, there's a variable base, so I won't be able to do that again. It is the same base, however, so I can add my exponents. 5 plus 6 is 11. So that's y to the 11th. This is what we talked about with our distributing, right? So negative 5x times x is negative 5x squared. And negative 5x times negative 7 is positive 35x. So when you've got that number right on the outside of the parentheses, distribute it throughout the parentheses. We don't have like terms after that, so we leave them as their separate terms. Ooh, raising a power to a power, right? So start with 3 to the 4th power. Well, let's do on our graphing calculator 3 caret 4. So 3 to the 4th power is 81. And now it's x cubed to the 4th power. So because we've got this situation going, we actually multiply those together. 3 times 4 is 12. So x to the 12th. 81x to the 12th is our answer. And now be careful on the next one because this a is being raised to the 4th power as well. And currently that a has a 1 on it. So 1 times 4 is a to the 4th. B has the 3 times 4, which is 12. So a to the 4th, b to the 12th is your answer. Number 12, these are the ones where we kind of regroup in our heads. So 3 times 4 is 12. M squared times m is m cubed. And n times n cubed is n to the 4th. 13, do that distributing. So I get negative 6x cubed minus 12x squared plus 27x. Oh, 14. That's actually one of the scenarios we're going to look at today. This is multiplying special binomials together because it's exactly the same binomial times itself. So we're going to go into the pattern of this today. All right, but let's just start by FOILing. So first, x times x is x squared. Outer, x times negative 6 is negative 6x. Inner, negative 6 times x is negative 6x. And last, negative 6 times negative 6 is a positive 36. So now combine these like terms in the middle. Negative 6x plus negative 6x, you get x squared minus 12x plus 36 as your final answer. We'll talk about the pattern there. Last but certainly not least, you can use the box method, or you can use the method like I do where I kind of line up my like terms vertically. So 3x times x squared is 3x cubed, and 3x times negative 3x is negative 9x squared, and 3x times 5 is positive 15x. And then we've got 4 times x squared, so this is a positive 4x squared. Notice I lined that up underneath the like term of negative 9x squared. Then I've got 4 times negative 3x, so that's going to be a negative 12x. And then I've got 4 times 5, which is a positive 20 at the end. Notice that 20 at the end is not lined up with any like term because there isn't a like term with it. Now I'll vertically add. There isn't anything else like the 3x cubed, so that goes first. Then I get a minus 5x squared, and then I get a plus 3x, and then I get a plus 20 at the end. There you go. All right, make sure you understand all that stuff first. Okay, that's all the past. That's the majority of the stuff because really today there is actually nothing new. Okay, I am just going to look at some scenarios that are special situations of multiplying binomials together. But the bottom line is, while I am going to point out patterns today that you can use to get to your answers quickly, you do not ever have to. You always have the option of foiling. And so that is something that I want you to keep in mind is that I'm not actually doing anything new today. With everything that I do, you could foil to get your answers. I am going to start just by talking about how we can kind of apply this stuff because sometimes that gets missed as to why are we talking about this, right? You know, variables stand in place of a number we don't know yet. And this is a place where we have a number we don't know yet. Okay. So we've got the length of a rectangle is 5 inches greater than the width. Whenever you read about a shape, draw the shape. So, sorry, just trying to get comfortable and closer to this. I'm going to draw a rectangle. Okay. The length of a rectangle is 5 inches greater than the width. Well, I'm going to represent the width with a W. 5 inches greater than that would be the length, W plus 5. So there you go. Now, an expression for the width, oh, I just said it, W. An expression for the length, W plus 5. Now, area is length times width. And that's what they're saying right there. So let's multiply those together, right? So W times W plus 5, well, look at that. That's going to give me my area. And that is just a simple distribution. W times W is W squared. And W times 5 is plus 5W. That's going to be my area. Cool, right? Find the area of the rectangle when the width is 3. Well, that's pretty easy, right? Because you just put a 3 here and a 3 here. So 3 times, well, let's see, what's 3 plus 5? 8. What's 3 times 8? 24 inches squared. Now, what if the length is 9? So 5 plus what gives you 9? 4. So that means my width is 4. So 9 times 4 is 36 inches squared. when that's the case. So see, I used those expressions to help me find different scenarios for my areas. Okay. Kind of neat. Used those expressions, those polynomials. Okay. Let's talk about perfect square trinomials because this is pretty cool. Okay. A perfect square trinomial comes from a binomial times itself. So just like 3 times 3 gives me 9, and 9 is a perfect square. If I take x plus 4 times x plus 4, its result is a perfect square. It's a 3-term polynomial, a trinomial, that is a perfect square because it came from a binomial times itself, or what we like to refer to as a binomial squared. Now, here's the deal, and this is after teaching for the last 16 years. Every single year, people do this wrong if they don't heed my big, big, big piece of advice, which is if you see a binomial squared, write it out as the binomial times itself. Because what people forget when they see a binomial squared is that this is a binomial times a binomial, which means you have to FOIL. You must FOIL. You cannot just square the front and square the back. That won't give you the right answer. There's going to be a middle. That's why it's a trinomial. So you have to write it back out as binomial times binomial and FOIL it. X times x, x squared. X times 4 is plus 4x. Interesting. Because 4 times x is plus 4x. And then at the end, it's 4 times 4 is 16. So notice, how do I get that middle? It's the same thing added together twice. 4x plus 4x, 8x. So what could I have said to myself to get the middle quicker? Oh, this times 2. And that's what they're showing you right here. That's the pattern. Square the front, square the back, multiply these together, and multiply it by 2 for the middle. If you don't know that and don't understand that, that's okay. Just FOIL it like I just did. Just FOIL it. And again, write this out. 3x minus 5 times 3x minus 5. So you don't forget that this is FOIL. So 3x times 3x is 9x squared. 3x times negative 5. Well, that's negative 15x. And then notice I'm going to get another negative 15x right here. So I can just do that quick in my head. Negative 15x times 2 is negative 30x for the middle. And now negative 5 times negative 5 is positive 25 at the end. See, that slight little trick just helped me get the middle quicker, not having to go through this part. That's all that this little trick is giving you, okay? It's giving you a little bit of help to get what that final middle term is. Do you need to use it that way? No, because you can FOIL anytime you want. Do I use it? Yeah, of course. I rewrite. Whenever I see a binomial squared, I rewrite it as the binomial times itself. I'm not going to mess around with trying to do the whole thing in my head. See the binomial times itself. Now you can use that little trick, right? X times x is x squared. X times negative 8 is negative 8x. Negative 8x times 2 is negative 16x, because I would have done that again here. And then negative 8 times negative 8 is positive 64 in the end. There you go. Let's do it again. X plus 3 times x plus 3. Okay, the front terms multiply together. X times x is x squared. And then the outer and the inner, right? So x times 3 is 3x. Notice I would get that again. What's 3x times 2? Plus 6x. 3 times 3 at the end, plus 9. Have you noticed, by the way, that the end is always positive with these? And that makes sense because these are always the same sign. And we talked about that before, that same sign times itself gives you a positive answer. So with these guys, you always have a plus at the end. Kind of nice. Something to rely on, right? So 7x minus 6 times 7x minus 6. Okay, so again, I can just FOIL this just as easy. So don't worry about it if you need to. But let's think 7x times 7x, well, that's 49x squared. Then 7x times negative 6, well, that's a negative 42. And, negative 42x. And what's negative 42x times 2? Negative 84x for the middle. And then negative 6 times negative 6, positive 36 for the end. That's all. That's it. That's it. That's all. You can use that nice little hint to get the middle a little quicker. Otherwise, just FOIL it and you're still getting the middle. It's not that much longer. I'm just trying to point out patterns to you, okay? Give you more practice with foiling and point out patterns. Those patterns are going to be important in chapter 7. So I kind of am trying to get you early into looking at those, right? So creating difference of two perfect squares or multiplying conjugates together. You can think of it as either way. Eventually, conjugates becomes in algebra 2 a thing that you use a lot. Speaking from someone who also teaches some algebra 2. Okay. You're going to hear that word a lot in algebra 2. So it's good if you can kind of recognize that situation early on. And what that situation is when you have two binomials multiplied together, where their terms in the front and back are the same in both binomials, but their signs between the terms are different. And when that happens, there's this really cool thing that occurs. And I'll show you through foiling this first example. And it's an awesome thing that then happens for us. And it's x times x is x squared. X times negative 4 is negative 4x. 4 times x is positive 4x. You're probably seeing it right now. And 4 times negative 4 is negative 16. And what happens to these two terms in the middle? Well, they're opposites of each other, so they cancel out to 0. So what's the only thing that's actually left? It's square of the front minus square of the back. That's why we call this the difference of two perfect squares. Perfect square minus perfect square. Because what happened was those two things in the middle being opposite signs of the same term add up to 0. So that term, that whole x term is just gone. And it's really just the square of the front minus the square of the back is your final answer. I'm going to show you the work on number 2 again, and then I'm just going to start using that hint. Okay. So notice same numbers, different signs between them. So this is going to result in difference of two perfect squares. 3x times 3x is 9x squared. 3x times 5 is plus 15x. Negative 5 times 3x is minus 15x for the middle. And then negative 5 times positive 5 is a negative 25. So now these add up to 0. You get 9x squared minus 25 as your final answer. All right, think about it. X times x is x squared. 8 times 8 is 64. What is going to be the sign between them? Well, because they're different signs here, it's going to be a minus 64. There you go, because we know the middle is going to cancel out. X times x is x squared. 3 times 3 is 9, minus sign in between because the middle terms will cancel out. 7x squared is 49x squared. 6 squared is 36. Different signs, so subtract. Middle had canceled out. When you see that situation, that's what you can know was happening. Okay. Alrighty, guys. Well, that is actually it for chapter 6. So I'm just going to zoom out so you can see that we did these two special situations here. There we go. Okay, you can see we did these two special situations here, but again, in both potentials, you can just FOIL if you don't like using those special tricks. That's absolutely fine. Okay, they are just patterns I want you to start thinking about now before we get into chapter 7. In chapter 7, when we start factoring, those are the patterns that are going to help us accomplish our factoring goals. Okay, if you need anything, come to class, send me an email, but make sure you're practicing all this. It's over and over and over, and it's so that you're ready for your chapter 6 exam. Okay, good luck. Let me know if you need anything. I shall see you soon, algebras. Bye now.